Hey everyone, it's Shubha this side. Today I will be presenting you matrix multiplication using mesh in linear time. Let's have a look. Now let us know what is the agenda of today's session. First, about mesh network and matrix multiplication. Second are the examples. And third, about the algorithmic analysis. A mesh network is a type of computer network topology in which each node in the network is connected to multiple other nodes, forming a mesh of connections. In a mesh network, every node can communicate directly with every other node without needing to go through a central router or switch. Mesh networks can be more efficient than traditional hierarchical networks because they can distribute traffic more evenly across the network. Matrix multiplication in linear time can be achieved using a mesh network. In this approach, we break down the matrices into smaller submatrices and distribute them among a network of processors in a mesh topology. Each processor multiplies its assigned submatrices and sends the results to the appropriate neighborhood processors. The final result is obtained by aggregating the partial results computed by each processor. Let's illustrate this with an example of multiplying two 4x4 matrices A and B. We can divide each matrix into four submatrices of size 2x2. A11, A12, B11, B12, A21, A22, B21 and B22. We can distribute these submatrices among a mesh network of processors as follows: P1, P2, P3, P4. In short, there will be a lot of up and left shifts going on to calculate the results, but to keep it simple, I have just shown how each processor is responsible for computing a subset of the resulting matrices. We can assign the submatrices to the processors as follows: processor 1, C11 equals A11 into B11, processor 2, C12 equals A11 into B12 and so on. Each processor computes a partial result by multiplying its assigned submatrices and sending the result to its neighbors. For example, P1 sends C11 to P2 and P3 and receives C21 from P3 and C12 from P2. The final result can be obtained by aggregating the partial results computed by each processor. So here you can see the resulting matrix multiplication using a mesh network. Now let's deep dive into the algorithm of the matrix multiplication using mesh. So what should be the input? Two matrices A and B, each of size n cross n. What should be the output? The product matrix C equals A cross B, also of size n cross n. Number 1. Divide each matrix A and B into n square submatrices of size n by root p cross n by root p, where p is the number of processors in the mesh network. Distribute the submatrices among the processor in a mesh network with each processor responsible for computing a subset of the resulting matrix C. Number 3. For each processor I, do the following: A. Initialize the local matrix Ci to 0. B. For each pair of submatrices Aj and Bk that are connected to processor I, compute their product Aj into Bk and add it to Ci. 4. Exchange data between neighboring processors to compute the contributions to Ci from submatrices that are not directly connected to processor I. 5. Repeat steps 3 to 4 until every processor has computed its local matrix Ci. 6. Aggregate the local matrices Ci from all processes to obtain the final result C. 7. Output the matrix C as the product of A and B. So this algorithm has a time complexity of n square by p, which is linear in n for a fixed number of processes. By increasing the number of processes, we can achieve even faster matrix multiplication with a time complexity of O of n square divided by log p, where this almost tends to a linear time, big O of n. That's all about it. I hope you liked this presentation. If you want, you can follow me on my socials. It's Shubhosh signing off.